In our previous video, we looked at patterns of coefficients and variables that we get when we expand the simple binomial a plus b to different powers. Well, we can summarize that pattern with a very, I don't know if it's a simple formula, but with one formula that involves sigma notation. So here's the formula, and this is called the binomial theorem or the binomial formula. A plus b to the n is the sum, as r goes from 0 to n, of n select r times a to the n minus r times b to the r. So we're going to fill in a value for n. We're going to let n equals 4 to match the pattern that we've been looking at for a plus b to the fourth. And we're going to see how this formula works. So I'm going to write down a plus b to the fourth. Okay, so there's my n equals 4. And I'm going to put a 4 every place I see an n in the formula. So I have the sum, as r goes from 0 to 4, of 4 select r, a to the 4 minus r, b to the r. Now, you might think, what in the world's r? Well, r is just the term number. We have to start with term 0 and we end with term 4, giving us 5 terms. If you go back up and look at a plus b to the fourth, it has 5 terms. 1, 2, 3, 4, 5. Corresponding to how many ways can I select 0 out of 4, 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4. So that's what those term numbers mean as far as the binomial coefficient goes. Here's the a raised to some power, here's the b raised to some power, and this part tells the coefficient. So I'm going to actually label that this is the coefficient, and then we have our two variables raised to various powers. Okay, so let's go ahead and start listing just like we've always done for expanding a sigma notation. Let's just start with r equals 0. So for r equals 0, I'm going to substitute 0 wherever there's an r. So I'm going to have 4 select 0, a to the 4 minus 0, b to the 0. So 4 select 0, a to the 4 minus 0, b to the 0. All right, well, what's 4 select 0? How many ways can I get 0 out of 4? 1. This would be a to the fourth. And this would be 1. B to the 0 is 1. So I get, what do I get? A to the fourth, my first term. Okay, so let's do the second term. Let's let r equals 1. So remember, I'm going to add whatever this is, plus, now I'm going to do 4 select 1. Oops, I don't need a parentheses here. 4 select 1, a to the 4 minus 1, b to the first. Okay, so 4 select 1. Well, how many ways can I get 1 out of 4? Is 4. We did this already. A to the third, b to the first. So my second term is 4a cubed b, which is what I expected it to be. Okay, now let's do the third term. I'm alternating colors just so you can tell when I go from one term to the other. So now plus, let's make r equal 2. So r is 2. This is 4 select 2. A to the 4 minus 2. B squared. So 4 select 2. If I hadn't already done this, what I would be doing, I would be doing, for 4 select 2, I need a little spot for this. So I kind of 4 select 2, remember it was going to be 4 factorial over 2 factorial, 2 factorial, and when I did that I got 6. So kind of put this in a little box here. So this is 6 and times a squared times b squared. So 6a squared b squared is my third term. Okay, 2 more. R equals 3. So plus 4 select 3, a to the 4 minus 3, b to the 3, or the third. So 4 select 3, we found out that that was 1. I'm sorry, that was 4. This was a to the first, b to the third, so plus 4ab cubed. Once again, I'm kind of whipping through the binomial coefficient part since we just went through and evaluated all these on the previous page of our notes. So if you need to go back and look at how did we get 4 select 3, you can see that. And then the last one, r equals 4. So plus 4 select 4, a to the 4 minus 4, b to the 4. How many ways to get 4 out of 4? 1. This would be a to the 0, which is 1, times b to the 4th. So this whole thing just simplifies to plus b to the 4th. There are my 5 terms. So this formula, by substituting in the different values, the term numbers, which are r equals 0 through 4, gives me the whole expansion. And this would work for any value of n. Specifically, what we're going to be using this for is we're going to put in different values for a and b. Rather than just a and b, this might be 3x and this might be 7 or something like that. And then we're going to see how that works with the formula and how that works with our binomial expansion pattern above. So more on that in the next video.